All right, it's recording. Exercise 3B, multiplying, dividing fractions. So last session, which is yesterday, you learned how to add, subtract. And I showed you the reasoning as to why adding, subtracting works. Okay? Today, I'm going to show you the logic to the rules for multiplication. So here, I want you to fill in, when you're doing multiplying fractions, you are actually doing repeated addition of fractions. Okay, write that in. So addition. Addition means plus. Okay. Here's an example. If I asked you, what's 4 times 3 on 2, or 4 times 3 over 2, the logic of what you're saying here is you're saying you've got 4 groups of 3 on 2. So this is one group. That's one group. Plus a second group. Plus a third group. Plus a fourth group. That's what 4 times 3 on 2 actually means. If you think about it logically, what this actually means as well is that your pizza is cut into 2 pieces. So you got halves, right? So these are halves, half of a pizza. You got 3 of them. So it looks like this. 1, 2, 3. That's 3 half pizzas there. Plus another 3 half pizzas. Plus another 3 half pizzas. Plus another 3 half pizzas. So how many half pizzas do I have in total?
4. I think there are 3 half pizzas.
3. How many of these half pizzas? These are half pizzas. See, each one I'm drawing is half a pizza. I've got 3 of them. So that's 1, 2, 3 half pizzas. 4, 5, 6. 7, 8, 9, yeah, thank you. 12. Now, yeah, I don't know. So, the logic here, that you can add, do repeated addition, but there's a pattern. 3 plus 3 plus 3 plus 3. Another way of writing 3 plus 3 plus 3 is 4 times 3. Notice the denominator, we didn't change. And the reason why is because you're adding half pizzas. That's the type. So that's the same type for all of them. That's why it's 4 times 3 on the top. But this is interesting because how do you write 4 as a fraction? How do you write 4 as a fraction again? 4 over 1. This is the same thing as writing 4 over 1 times 3 over 2. What's convenient is we found that 4 times 3 is actually the numerator. So here, I want you to fill in, it actually ends up being 4 times 3 in the numerator, and on the bottom, it's actually just one group of 2. That's why you only got the answer of 2 on the bottom. That's why this works out to be 12 over 2. So, what you learnt in primary school, which they may not have shown you this way, but they would have told you when you're doing multiplication of fractions, they say you multiply top with top, and then they say bottom with bottom. But that's the only reason why they say that is because clearly when you're adding the fractions, the numerator is just how many groups do you have in the numerator, and on the bottom, it's how many groups on the bottom. Now, that means when you're multiplying fractions, it's much easier than adding and subtracting, because adding and subtracting, you have to find the lowest common multiple. Timesing, you don't. Here's an example. Let's do this example, first one. If I gave you 2 over 1 times 1 over 2, by the theory that we know, it's just top with top, bottom with bottom. So your answer should be 2 times 1 in the numerator, and then 1 times 2 in the denominator. The answer then gives me 2 times 1, which is 2 on the top, and then 2 on the bottom. But what's 2 over 2 the same as? 1, because 2 over 2 just means 2 divide 2. And 2 divided by 2 equals to 1. So you're thinking, all right, well, I seem to understand multiplication of fractions where it's just top with top, bottom with bottom. This is what a lot of students do. This is not the skill I want you to learn at year 8. So at year 8, if I gave you the second example now, so example 4, what a lot of students do is they do this. Top with top, bottom with bottom. What's the problem? You're going to end up with 25 times 18 over 15 times 20. whilst we can do that, that's a pain. Without a calculator, you're going to now have to go back and go, how do I do 25 times 18? And then most of you will already know that. 15 times 20, double 15 is 30, times an extra 10 is 300. But to do this, that's a pain. Let's work it out on the calculator. Anyone know what 25 times 18 is?
200.
200? I think it will be much more than that.
450.
25 times 18. 450. So, if you did do it this way, your answer would have been 450 over 300. That's a big fraction. But then to reduce 450 over 300 down even further, you then now have to find the highest common factor that goes into 300 and 450. Anyone know what that number is?
1.
Well, the highest common factor. There could be 15. I can see 10 already because they both have 0.
50.
There could be 50 because I can see that the 50 goes in all of them. So if you really think about it, the answer, if you can figure it out, it actually ends up being 3 over 2. Now, to get this down to 3 on 2, can you already see how many roadblocks there are? Roadblock number 1. Not all of us know multiplication tables. Okay, so from exercise 1B, from the very first time I met you, exercise 1B, I saw not everyone can do that. So you would have stopped right here. Or even if you were able to do it, or you had a calculator, you cheated, you go down to this step. Finding the highest common factor to then drop down to 3 on 2 is a pain to do. So the skill, even though I taught you, Ashwin, as I'm teaching this, even though you know it, I don't know if you know this bit. So I want you to copy notes and not play around. This bit here, what I'm interested in is, it's not the top with top, bottom with bottom, because most students know that. The problem is here. This is where students stop. And I see it all the time. Every time I put in a test, students don't finish this line. But they finish this one. They don't finish this one. And that's because I know what stops you guys. Okay? I know that you like the simple. I know you like the shortcut. But that's the problem. The easy road is the ones that you tend to trip. And I don't want you to take that. I want you to actually go through the foundation. So here, what's the alternative method than doing top with top, bottom with bottom? Let's have a look. In primary school, you learnt what we called cross simplification. Now 25 on 15 times 18 on 20. Let's do this. Instead of 25 on 15, we can simplify this a bit further using exercise 3A, equivalent fractions. We know we can make that smaller. Now 25 on 15. What number goes in both 15 and 25? Yes, Ashwin?
So 15 it will be like 5.
5. So 5 goes in 15. 5 also goes in 25. So that gives me what new fraction will I get? 5 goes into 25 5 times. 5 goes in 15. I don't know why. What's going on today? Next one. 18 over 20. What number goes into 18 and 20 to make this fraction smaller? 2. So if I divide top by 2, I divide bottom by 2, I should now get 9 over 10. Very good. Now that is a much better fraction than 25 on 15 and 18 on 20 to multiply to each other. But if I multiplied it right now, if I actually did top with top, bottom with bottom, it's still not the most simplified answer. You'll see 5 times 9 on the top gives me 45. 3 times 10 on the bottom gives me 30. That's not 3 over 2. That means there's something here that I can still simplify. Now, I want you to look at this fraction. 5 over 3. Can you make that smaller?
No.
9 over 10. Can you make that smaller? No. But what's the technique, Ashwin?
Cross.
Now, 3 and 9 you can. But I don't want you just to memorize this because this is what primary school teachers would have taught. They call it cross simplifying. But they might not have explained to you, why can you do that? Why can I actually just take the 9 and the 3 and simplify that for the sake of doing it. Where'd that come from? How can I just do that? We know how to do 5 and 3. I proved to you yesterday why equivalent fractions, whatever you do to the bottom, you do to the top. But I never taught you that whatever you do on the bottom of one fraction, you can do to another on another fraction. I never taught you that. Why is this true?
Because they both have the highest common factor is 3.
Yes, but they're separate fractions though. Why is it that I can just take this one and that one?
I think it might be because it's still a fraction. Like a fraction is something divided by something.
No, that's not the key part.
Is it because 9 is multiple of 3?
No, it is a multiple, but it's not because of that. Anyone have a clue? Why is it that we can simplify? Here's the logic. You learnt this back in year 7. It's called commutative law. Sully, thank you. Commutative law. Remember, we said top with top, bottom with bottom. 5 times 9 is 45. But who's to say that I have to write it as 5 times 9? See, commutative law says that if you're timesing, you can also do the reverse. 9 times 5 is still 45 on the top. Doesn't change. So I haven't changed the fraction. And then 3 times 10 on the bottom, that's still okay. 3 times 10, it's there. 9 times 5 or 5 times 9 actually doesn't matter. Now, if I write it like this fraction, can you see 9 over 3, like you said before, yes, they do have a common factor. Then through our equivalent fractions that we understand, that's why we can reduce this down. Same thing with 5 over 10. That, as an equivalent fraction, we can reduce. So none of that did I do anything that we didn't learn. We already learnt all this, right? But the reason why I show you this is because when I have students in year 9, 10, 11, even my accelerated group, they were making this mistake. I give them x plus, they're doing it to x squared, over x plus 1. One of the common mistakes that students do is because they don't understand when you can simplify and when you can't and why you can. This is what they do. They see x, 1 on the bottom, 1 on the top, and then they say, oh, well, there's another x here, so they take it away. The problem is you can't do that. There's that plus sign. It doesn't work for plus. All of this was only possible because it's times. Equivalent fractions can be reduced because it's times, not add. That's why they can't do that. Had I taken this off, they would have been okay. They would have been right. But that's why learning your basics, you won't make the mistakes even the accelerated group would still make a mistake on. Okay, yep.
Does cross simplifying matter if you're timesing 3 fractions?
No, because exactly by the same theory, if I gave you, say, 2 on 8 times 12 on 15 times, let's do 20 on 10, right? The law still states that you can swap all the orders on the top. So it doesn't have to be 2 and 8. I could have actually swapped it to be 10 over 8 times 12 on 15, and this is 2 on 20. The answer still be the same. So you can swap all the tops and you can swap all the bottoms so that the fractions can be simplified. The reason why your primary school teachers wouldn't have taught you this is because that's confusing. There's a lot of thinking behind the fact that you can swap this order. And that's the thing about maths. Maths is meant to be problem solving. It's like a puzzle. Your idea of your training is to train you to think outside the box, not to memorize. You guys are not robots. I'm teaching you to think. So that's why this is difficult for a lot of students. And that's why in primary school, they just teach you to regurgitate. We teach you to memorize, like a language. We say, do this when you do this. Do this when you see this. Do this when you see this. That's why it's confusing, because you're memorizing them. Yeah? I don't want you to memorize. The beauty of maths is actually about you thinking how to solve a problem multiple ways. There's a lot of ways to solve it. You don't have to do it this way. Okay? So that's why in primary school, instead of swapping it, your teachers would have been saying, oh, just cross these two since we know it's still the same as 9 over 3 and 5 over 10. That's why they call it cross-simplifying, and they don't actually do it properly. This is the proper way. You're meant to swap it. Then you can simplify it. 9 and 3 simplifies down to 3 over 1 because 3 goes into 9 3 times, 3 goes into 3 once, and then 5 goes into 10 twice, and 5 goes into 5 once. So then your fraction now becomes 1 over 2. Now, that's as simplified as possible. Top with top, bottom with bottom. You get 3 on 2, which is the correct answer. Can you see that? So what I'm trying to get you to practice in this exercise when you're doing 3B multiplication, I'm more interested in this. I'm interested in your method to get there. Okay, because that skill to get there and understanding where it comes from, that's what I want you to understand. Because when we start doing algebra and all that, the stronger your foundation, the less mistakes you make with algebra. If you're memorizing, you will make mistakes. So, here's your shot now. I want you to try this one. Just on the bottom it says, try 32 over 15 times 20 on 28. I don't want you to do 32 times 20 and 15 times 28. No calculator. Simplify this for me. I'm going to pause the video. You're going to get 3 minutes. Here we go, 3 minutes. So that's the answers for the try. I want you to flip over to the next page. Shh. Flip over to the next page. Let's go, next page. All right. Let's have a look. Forte. Eyes and ears towards the board. Dividing fractions. Back in primary school, when we divide fractions, what do you have to do again? When you divide a fraction, you do the reciprocal. What's reciprocal mean again?
Making opposite.
Yes, but there's another word that starts with F that most students... Flipping. So why do we flip is what I want to talk about today. So when you're doing division, you usually flip the fraction. So instead of 1 over 5, it becomes 5 over 1. So fill it in. When you're dividing fractions, the technique is do the flip or the reciprocal. Here's the proper name. Reciprocal. And that just means flipping the fraction and then changing the division sign to a... Very good. So that makes it from division becomes times. We know how to multiply fractions. So we say then top with top, bottom with bottom, 3 times 5 on the top, 4 times 1 on the bottom, and you get your answers 15 on 4. My question.
You know the 2 girls that came to our class that other time, they showed us this method to memorize it, and it's called the KFC method. So K stands for keep, so you keep the first one the same. Then flip, which is you flip 5 to 1, and then C is change the operation.
Oh yeah. That's a good way for you to memorize. KFC, keep the first, flip the fraction, and then change the sign. Technically KCF.
Yeah.
But it might help you remember by KFC. All right. Now, that is a good acronym to remember the technique. But remember, I don't like teaching you to memorize things. I like you to think. Why do we flip the fraction? Someone told you to flip. Someone taught you some acronyms now. KFC. But why? Why do we flip when it comes to division? Who came up with that? Why do I have to do that? Anyone know? Well, that's the thing. I don't want you to think maths is just because you just do. That's how most students think. Let's do a bit of logic. You know how you got one of the basic logic here. If you got a half of a pizza, right? So think of a whole pizza. So I'm going to draw a whole pizza. If you half that pizza, it looks like this now. So that's half a pizza. What's half of a half pizza? A quarter. See, we all know that. So half of a half pizza gives us a quarter, right? So if we were to do that, what is half of half? It's a quarter. So that's how we know, right? But another way of thinking about it, when we do half of 10, what are you guys really doing? Divided by 2. So when I say half of half, Yes, I know it's a quarter, but it also means half divided by 2. You're taking a half and you're cutting in 2s, right? So how do we work out half divided by 2? Well, what's 2 as a fraction? All right, Sully, I'm going to get you to move over here. Thank you. Two as a fraction is 2/1. That's your fraction, 2/1. But then here, how do we say, why do we flip it? Why do we flip this? This is the logic. Sorry, team, can I have you focusing eyes and ears towards the board? Why do we flip it? I know you can memorize it, but why do we flip it? Here's the logic. We already know half. Remember, with equivalent fractions, you can times it. Whatever you times to the bottom, yeah, well, they're here. Whatever you do to the bottom, you do to the top, right? But who said that you had to times by 2 and times by 2? So the logic was, you said, whatever you do to the bottom, you do to the top. I could actually then say, well, why don't I times this by 1/2 and times the bottom by 1/2? Because that still works. Because if you can times by 2 on the top, you can times 2 on the bottom, then you can times half on the top times half on the bottom. Which should still be the same. Now, 1 times half. What's 1 times half? One group of half. You only got a half. So that's why I got half in the numerator. But then what's half of 2? 1. So half of 2 is 1, but 1 as a fraction is 1 on 1. Right? This is where, as you can see, half of 2 is 1 on 1. And even though when I work it out, it actually ends up being half right here. To get that half there, that is the same thing as multiplying by 1 on 1. And on the bottom, can you see I'm actually timesing it by, half. Can you see that when I multiply it by half, what do you actually end up getting? Half times a half, we already know, actually ends up being a quarter. But then 2 times a half is 1. So what's interesting is that at the end of the day, as you're multiplying, whatever top and bottom you do, when you divide by 2, is actually the same as you timesing by half. That's why they say whatever you do when you divide by 2/1, it is the same thing as saying half times a half. Okay, I'm getting the sense that you're confused here. So let's do this again. Maybe I'll just rub this out. I want you to think about this. I'm going to rub all this out again. So we know that what you do to the bottom, you can do to the top, right? Now, maybe I'll make it a bit clearer. Half, you know when you write divide is the same thing as over. True? So if I write 3/2, that means 3 divide 2. True? So when I say half divided by 2/1, that's the same thing as you writing half over 2/1. Fair call? Yeah, so 3 divided 2 is the same thing as writing 3 on the top, 2 on the bottom. Half divided by 2/1 is the same thing as writing half on the top, 2/1 on the bottom. Yeah, so I'm going to color code it. Top, bottom, top, bottom. So far, so good? Then, what I'm trying to say here is, now that you've got the numerator and denominator, remember I said you can do whatever number you want. Now, the nice thing is, if you can times 2 on the bottom times 2 on the top, you can times the top by half. You can times the bottom by half. What's nice, half times a half, which we already know, top with top, bottom with bottom, that gives me a quarter. So quarter in the numerator. I'm going to color code it, so this is yellow, numerator. On the bottom, 2 times 1 and 1 times 2 is the same thing as writing 2/2. I'm going to color code it again. This is the bottom. This is the top. But we already know that 2 divided by 2 is 1. So if this is 1, then that's the same thing as saying a quarter over 1. But a quarter divided by 1 is just a quarter. So what have I done? I went from the very first line up here when you said, what is a half divided by 2 over 1? This actually was the result of you actually doing this step here. That's why, half times a half there, that's why we say when you're multiplying, this is the first number, that's why you keep. So the first number you keep, first number is still a half. This is what you're dividing by, and notice it changes. KFC, right? This one was 2 over 1, that's what you began with, but actually it was the same as the reciprocal. And that's why the quarter is actually the same, because I've kept everything the same rules that I've taught you. 3a was equivalent fractions. Whatever you do to the top, you do to the bottom, and I did that. So there was nothing wrong with me, there's nothing wrong with me multiplying half and half. All I did was just rewrote what I saw. Half divided by 2 over 1, half goes in the numerator, 2 over 1 goes in the denominator. I times the top by half, times the bottom by half, and I get a quarter. So then that's why they learnt, oh wait, let's not do all those steps. Let's do a shortcut. And that's why you guys have learnt the shortcut that we can do from dividing, we can change it to something that we know, which is times. Because the person who invented fractions did not know how to divide fractions. There was no way to do it. We only knew how to times. The reason why we know how to times is because it's repeated addition. So because of that, they said, well, how do I make a division a times? That's what they were doing. And so they figured out, it's like, oh, wait a minute. If I changed it to times whatever I want, I can times half on the top times half on the bottom. It simplifies the fraction. And that's why it works. So this is the theory. What's nice about this is this bit. When I give this to my mainstream year 9s, year 10s, even sometimes my year 11s, they don't know how to do this one. So if I gave them this, 3 over 5, 7 on 2, they get scared. They have no idea what that means. But I'm hoping that you, after seeing what I'm doing, this just means 3 over 5. This symbol here means divide. This is your fraction. We all know how to do that. Yeah? So this looks scary. But if you understood the theory, you can do that. That's why when I get to year 9 and 10s and I give them something like, 2x over 3 over 4 fifths, I can tell who can do it and who can't based on their algebra and whether they can solve that. That tells me a lot about their fractions. Students who can tells me they understand this. They also can understand that theory.
Is the answer 10x over 12?
The answer, well, let's work it out. For those who are interested, let's work this one out. This means top number, so 2x on 3. This symbol here means divide. And what am I dividing by? I'm dividing by 4 or 5. But we know how to divide now. When you're dividing KFC, keep the first one, flip the second, change the sign. So here we go. We now have 2x over 3 times 5 over 4. How do you times fractions again? Top with top, bottom with bottom. Now 3 times 4 on the bottom we know is 12. And out of curiosity, do you guys remember from last year, what's 2x times 5? Very good.
Or you can simplify.
Yes. Very good. That would have been the proper answer. So 2 goes into 10, 2 goes into 6. Now, obviously, I'm teaching you something that you're going to learn in Term 3. But you can see, if you can understand what I just went through, you've learned something. You've learned the difficulty of the theory. But if you get the theory, you can do that. That's what my Year 9s do. So that's what I mean. Year 9, Year 8, Year 7 is not a big jump. It's about you knowing your foundation. The stronger your foundation, the more you can do. Yeah? All right, team, that's it for today. So you can practice with the division, even with this one. You should be able to do this one now. So 1 over half just means 1 divided by half. See if you can do that. But that's it for today. You've got multiplication division. Hopefully I've demystified a lot of the things that you memorized. Thank you, team. I'm going to stop the video and you've got the rest of the session to yourself.